Hey everybody, welcome to video number 3 for Cumulative Review Packet number 13. We're going to start here with number 13. So, find all the zeros of the following function. So, when I look at this and I think zeros, I really think x-intercepts. So when I think x-intercepts, that means that y is 0. So I'm going to plug 0 in for f of x or y, and I'm going to set that equal to this entire function. Now, the interesting thing, though, is that the first thing when I see this many terms, I'm like, okay, I have to factor this probably somehow. Can I factor by grouping? Well, no, I can't, because I have 1, 2, 3, 4, 5 terms and not 4. So grouping right now is out. Second question, or something I ask myself generally first thing, is there a greatest common factor? Well, if I look at all 5 terms, there is. I can take an x out of everything. So let me at least do that. So we take x to the 4th, 3x cubed, 5x squared, 27x, minus 36. Grouping still doesn't work here because I have 5 terms and not 4. So this is where I seem like I'm stuck. Until I can remember that my absolute best friend in the world is my graphing calculator. So at this point, what I'd like you to do is grab your graphing calculator, and I would like you to graph this in your graphing calculator. Because if we see the picture of it, we can see where it crosses the x-axis. Before we do that, though, we're listing all the zeros. I know because of this x by itself, I already know that one of my answers for the zeros has to be 0, 0 because of this x right here. But please, pause right now if you'd like, and go graph this on your calculator. If you did graph it on your calculator, I know Desmos is not the same, but what I ended up was getting a picture that crossed the x-axis 3 times. Yours might look a little different. I could zoom out a little bit too so you can see more what it looks like. But I'm going to zoom back in. It looks like my zeros are 1, 0, 0, 0, which we already said is an option, and negative 4, 0. So I'm going to write 1 and negative 4 back here. So I could use 1 or negative 4 as an option. Now, please note that this is an x to the 5th function originally, so there should be 5 zeros. Some of them could be imaginary. Right now it looks like we only might have 3, but we need to prove algebraically that these are the solutions. So I'm going to start between the two. I'm going to start with 1, and I'm going to put 1 in a synthetic division box, and I'm going to write all of my lead coefficients. 1, 3, 5, 27, negative 36. And I'm going to reduce this polynomial down from an x to the 4th down to an x to the 3rd, so maybe we can factor it then. Again, this x is already gone to lead to this, so I'm only focusing on this piece. So bring down the 1. 1 times 1 is 1. Combine, get a 4. Multiply, get 4. Combine, get 9. Multiply, get 9. Combine, get 36. Multiply, get 36. Combine, get 0, which is excellent because that means my remainder is 0 here. That means that is definitely a solution. So I saw it on the graph. 1 is 100% a 0. This means now that this is really x cubed plus 4x squared plus 9x plus 36. And we're going to still set that equal to 0 because we still want to find the other answers. So far, I found out that 1 for sure works. So I'm going to add that to my list here. And I'm going to keep factoring this. Now I have 4 terms. So what if I factored by grouping? Take out an x squared here. Be left with x plus 4. Take a 9 out of here. Also be left with x plus 4. So I continue to factor and I get x plus 4 for one parenthesis and x squared plus 9 for the other parenthesis. We said before from our graph that we thought another answer was negative 4. Well, we proved that it is because we got x plus 4 equal to 0. So negative 4, 0 is another answer. So 0, 0, 1, 0, negative 4, 0 are all my real solutions. However, now if I set x squared plus 9 equal to 0, that would be x squared equals negative 9. Take the square root of both sides. Those are imaginary answers, guys. So my other 2 zeros would be 3i, comma 0, and negative 3i, comma 0. So 1, 2, 3, 4, 5 solutions, which makes sense because the highest degree is 5. Number 14, solve the following equation. Now we're dealing with rational exponents, and rational exponents really could also be written as radicals. But here's how I would solve this one. I would make sure to get x to the 2/3 by itself first before you do anything else. So I would remove the 2. Let's get rid of that. We have negative 3 x to the 2/3 power equals negative 147. Before you do anything with raising both sides to the reciprocal, I would really highly encourage you to divide by negative 3 next, because you want to make sure that x is by itself. So if you divide both sides by negative 3, you would get x to the 2/3 power equals a positive 49. Now what we can do is we could raise both sides of this equation to the 3/2 power, because over here, the 3's and the 2's cross out. But if I raise this side to the 3/2 as well, because whenever I do the one side, I have to do the other, we don't have anything crossing out this time. So we have x equals, what this really means is 49 to the 1/2 power, because the 2's on the bottom, and then you raise that to the 3rd. Now, the 1/2 power really means you are taking the square root of 49, then you're raising that to the 3rd. Now, when you're solving an equation and you take a square root, remember, when you take a square root, there are two answers, positive and negative 7, raised to the 3rd. Sorry about this pen. If you raise 7 to the 3rd power and negative 7 to the 3rd power, that would be plus or minus 343. And you could absolutely check to see if both work. They do. You could plug both positive and negative 343 into the original equation, which was here. And if you do, you would get negative 145 both times. Now, as a quick aside on this problem, if you are raising both sides to a fractional power, remember, if this number on the bottom is even, 2 or 4 or 6 or 8, you always need the plus or minus then. Because when you're taking a square root, 4th root, 6th root, 8th root, because the number on the bottom really means what root you're taking, you will always have the plus or minus in your answer. If this number is odd instead, you do not need to worry about plus or minus, because a cube root, 5th root, 7th root does not lead to plus or minus. Solve the inequality by finding critical numbers and checking your intervals on the number line. Okay, so this question has a decent amount of work, and here's why. In order to check for critical numbers, we need this thing to be equal to 0. So we need to move this piece to the other side. So we'd have 2 over x plus 4 minus 1 over 2x minus 5 is less than or equal to 0. So in the end of the problem, when we see less than, we want numbers that are eventually negative. The reason why this problem ends up being a decent amount of work, though, is on this side, we need to get a common denominator to combine these two. So this first fraction, the first fraction has the denominator of 2x minus 5. So the first piece needs to be multiplied by 2x minus 5, and the second piece needs the x plus 4. So if we're going to get that common denominator, we need to do this first thing. So here's what we have. 2 times 2x minus 5 over 2x minus 5, x plus 4, minus 1 times x plus 4 over 2x minus 5, x plus 4 is less than or equal to 0. Now I'm going to combine this into one big fraction. Now these two fractions have the same denominator, the denominator being 2x minus 5 and x plus 4. Now the numerator, what we can do is we can distribute here, we can distribute here. So if I distribute the first piece, notice I did not distribute on the bottom because we want them to be in parentheses or in factored form so we can get our critical numbers. So I'm going to write a note. You want to multiply out the numerator, but leave the denominator. So that would be 4x minus 10. Make sure you are distributing a negative 1 here. So minus 1x minus 4. So your numerator becomes 3x minus 14. Your denominator is 2x minus 5. And x plus 4 is still less than or equal to 0. So now that everything is simplified, you can find your critical numbers. Let me rewrite that. That's supposed to say Cn. This computer is tired from doing a lot of videos today. Critical numbers. So the critical number from the numerator, if you set this equal to 0, would be 14 over 3. The denominator, 2x minus 5. We have a critical number of 5/2. We also have a critical number of -4 from the bottom. So all those critical numbers are going to help us because we're going to draw a number line now. We're going to put them in order. Please remember, do not put a critical number, do not put 0 on your number line unless it is a critical number. And we do not have 0, so I wouldn't put it there because it might confuse you. So we have -4, critical number. We have 5/2, which is about 2.5, so that comes next. And then 14/3 is going to be a little larger than that. So 14/3 is going to go over here. What we need to do is decide what kind of dots go on these critical numbers, and we need to check numbers within each interval here. So our inequality is less than or equal to. So anything in the numerator is going to be a closed dot because of the less than or equal to. So this one's going to be a closed dot. However, your two pieces in the denominator, you can never divide by either. So the critical number, if you plugged 5/2 into here, that would cause this piece to be 0, and -4 here would cause this piece to be 0. So we can't technically have either one of these values, so both of them are going to be an open dot. So if there's anything in the denominator, whatever critical numbers you get from your denominator, they are always, always, always going to be open dots. Now time for the checking. Okay, so we need to pick values within each of these intervals. So I'm going to pick x equals -10 because I know it's for sure less than -4. In this interval here, I'm going to pick x equals 0. In this interval, between 2.5 and, let's see, that would be like 4 point something, I'm going to pick x equals 3. And then here I'm going to pick something much bigger like +10. And what we're going to do is plug these values into our most reduced version, which was right here. We want to plug it into 3x minus 14, 2x minus 5, and x plus 4. We want values that are less than 0. So if I take -10 and plug it into the top, that's definitely going to be a negative value. In the denominator, -10 here is going to be negative. -10 here is going to be negative. So we have negative over positive, which is a negative result. Did we want a negative result? Yes, we did. So this works, so this interval works. If we take 0 and plug it in the top, we are going to get a negative value. In the denominator, 0 in this first one is negative, 0 in the second one is positive. So that means that I have a negative over a negative, which is a positive result, which is what I do not want. I want negative numbers. If I take x equals 3 and plug it in the most reduced version, 3 times 3 is 9 minus 14, still negative on the top. 3 here is going to be 6 minus 5, so we get positive here. And 3 here is also positive. So we get negative divided by a positive, which is negative, which is what I wanted. +10 into here, positive on the top for sure, positive on the bottom, and positive on the bottom. So this result is positive, which I did not want. Are we done yet? Unfortunately, no. We need to answer our question in interval notation. So the two intervals that did work were the two with the check marks. So if we were going to represent this interval here and this interval here in interval notation, here would be my final answer. This is true from -infinity to -4 because we have an open dot. It is a parenthesis union. This second interval right here, there is a parenthesis on 5/2 because of the open dot. However, on 14/3, there is going to be a bracket because it is a closed dot. So there is my answer in interval notation. Last problem, write the quadratic function in vertex form. Please show the work algebraically. So hint, complete the square. So in order to complete the square, the first thing we need to do is make sure that our lead coefficient is not 3. It has to be 1. So we are going to divide every single one of these terms, including the y, by 3. So we'd have f of x over 3 equals x squared minus 8x plus 16/3. And our goal is to eventually complete the square, so we need the x squared and the minus 8x by itself. So we need to move the 16/3 to the other side. So we have f of x over 3 minus 16/3 equals x squared minus 8x plus something. So now as we're completing the square really comes into play. We need the x, both terms with x's on their own, Now we need to add a special number on both sides. And that special number is b over 2 all squared. The b this time is negative 8. So negative 8 divided by 2 squared is really negative 4 squared, which is positive 16. So we add positive 16 on both sides. The reason that we're doing this is we're trying to get this in vertex form, which is this. And we're trying to get it in this format, something quantity squared. Right now, after you add that special number, the side with the x's is always going to factor, and it'll factor nicely for us. Two numbers that multiply to be 16 and add to be negative 8 is negative 4 twice, which could really be written as x minus 4 quantity squared. On this side, this is really 16 over 1, and we need a common denominator to add these things. So this first one needs to be multiplied by 3 over 3. So we'd really have 48 thirds plus f of x over 3 minus 16 thirds. And then we can add these guys together. 48 minus 16 is going to be 32 thirds plus f of x over 3 equals x minus 4 quantity squared. Our goal at this point is to get this into y equals, so we want to resolve for f of x. So let's move the 32 thirds back to the other side. So we have f of x over 3 equals x minus 4 squared minus 32 thirds. Then I need to multiply everything, and I mean every piece, by 3. 3's cross out here, 3's cross out here, it does not here. So my final answer, which I'll write in the blank here, is f of x equals 3 times x minus 4 squared minus 32. So this is your answer in vertex form. So if I did ask you to graph it, you'd start at the vertex 4, negative 32, and then make it look like a parabola. The vertex would be 4, negative 32, because you need to think about what this is doing. This parabola is going to the right 4, and it's going down 32. So it's positive 4 because you're moving to the right, because it's the opposite of what you think in there. So this problem, again, the main way to get it right is to remember the completing the square process, that you need the lead coefficient to be 1, so you need to get rid of the lead coefficient. You need to move everything to the other side that doesn't have an x, complete the square, factor, it's always going to be the same parenthesis twice, move everything back over to the other side and get y alone, and that should be your answer. Alright guys, per usual, I hope that this video is as helpful as possible for you. I hope that it's a good resource to help prepare you for your test number 13. Alright guys, thank you.